Party people, what's going on, everybody? I wanted to get up here. Let me turn my light on too. Turn on the light. I wanted to get up here and do another live video. Like I said, I plan to keep doing these on a regular basis. Haven't figured out which day I want to do them on just yet, but when I decide, I will let you all know. In the meantime, do me a big favor. If you are watching this, whether you're watching it live or you're seeing the replay, do me a great big favor. I would appreciate it in advance if you would go subscribe to this channel. Share with a friend. If you have a friend that is a fellow student or a parent that has some students, then definitely share this video. So this was a video, someone on Instagram requested that I do this lesson. And I have a series of videos on solving systems of equations, but I only have one on the substitution method and the elimination method. And the graphing method is the third method of solving systems of equations. So I want to get on here. I won't be before you long. I'm going to break down a few things, show you how you can effectively graph a system of equations on the coordinate plane. So let me share my screen. I'll share the whiteboard. And for the sake of time, I'm going to draw a coordinate plane, but I'm going to do it in a interesting format. Let's go with this one. Let's just go with the lines. So we have a coordinate plane, for example, right here. And we are going to label this coordinate plane. Remember, there's the x-axis, there's the y-axis, doesn't matter which side you put those on. And then let's label these. Let's just go 1, 2, 3. Now, of course, we have positive 1, 2, 3, 4, 5, and 6. Positive 1, 2, 3, 4, 5, and 6. Negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. And then, of course, over here on the x-axis, negative 1, negative 2, negative 3, negative 4, negative 5, and negative 6. Now, for the first system that we want to solve, we have, let's say we have these two equations, y equals 4x plus 3, or we have y equals, and we have, it's not an or, negative x minus 2. Right, so if we're using the graphing method, then we want to actually graph both of these equations. Now, I won't get into the specifics of what method is the best. These equations, for the most part, are going to be in slope-intercept form. I probably will do a part 2 to where I'll give a couple systems of equation examples where the equations aren't in slope-intercept form. So you may have to maneuver them in order to graph them. But these are some simpler ones. So let's look at it. We have a slope of 4 and a y-intercept of 3. Now, when I graph equations from slope-intercept form, I graph the y-intercept first, which is 3 right there, and then the slope is 4. So from here, I can go up 4, 1, 2, 3, we're off the grid, and over 1. So approximately right there. And then I can go in the opposite direction down 4, 1, 2, 3, 4, and back 1. Let's do it again. 1, 2, 3, 4, and over 1. So then now I'm going to put a line through these to connect those points as best as I can. It's off a little bit, but no worries. Let's see if we can adjust it a little bit. But you get the idea. So you have this line graphed. And let's go to the next set. I guess I need to move this back up here because It feels weird at the bottom. So y equals negative x minus 2. Now in this one, y-intercept of negative 2 right there. And so we're going to say boom. And then let's say the slope is negative 1. Remember, it's just a negative sign, but remember that is technically a negative 1. I kind of drew that rather close, but this means the slope is negative 1, right? So from here, if it's negative 1, down 1, to the right 1, boom, down, right, down, right. Same thing there. And then we can go in the opposite direction. We can go here, 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 and here. And let's connect those with the line. Now, it's not perfect, but that's totally fine because I drew my own coordinate plane. Actually, it needs to be off a little bit. Let's see. That's still off. But anyway, the point is, as a matter of fact, let me do this again. Let me try it like this. There we go. All right, for some, oh, that's what I need right there. Now, this one, the graph is off, but the point is you graph these, you create the line, and then you actually find out what is the point of intersection. Now, because mine is slightly off, it may not be the exact answer. I'll double check it. I'm going to assume that the point of intersection is right here at negative 1, negative 1. But I can double check that, right? So this is what we're looking for. Where do those two lines intersect? Once again, my graph is off, but it should be negative 1, negative 1, right? So the solution is negative 1, negative 1. How do we know if this is the correct solution? Well, based upon the graph, right? Now, if we wanted to use the equations to figure out if this is exactly the right solution, then we can simply put in substitute our x and our y there. So if I have, let's see, negative 1 is equal to 4 times negative 1 plus 3, and that is the case. Negative 1 is equal to negative 4 plus 3. Negative 1 equals negative 1. So I know that that is the case. And then I can check it for the second equation too. It should hold true for the second equation. So negative 1 equals, this is a tricky one right here because you have the opposite of negative 1. So you make sure you have to put that negative 1 in parentheses and keep the 1 outside. Well, so negative 1 equals, the opposite of negative 1 is positive 1 minus 2. And 1 minus 2 is negative 1. So it is the solution, negative 1, negative 1. But that's the graphing method. That's one example. Let's clear this out. And actually, let's do another example. And I'm going to try to easily erase this without erasing the entire graph, so I don't take up time drawing a coordinate plane. Next time I know to have my graph paper ready. As a matter of fact, let's see, I can actually do that right now. So that's one method. Remember, there are 3 methods to solving systems of equations. All right, let's get me some graph paper. All right, here we go. All right, so we go, yeah. Make this a little smaller. All right. Yeah, let's see. Here we go. So the next example, let me see something real quick. Let me pull up this. All right, here we go. Let's get it. So the next example, we have same thing, but our equation is now going to be, let's see what we have. Y equals, let's annotate on this. So we have y equals -1/2 x minus 1. And then we have y equals 1/4 x minus 4. Now, it's a little blurry with this kind of screen. As a matter of fact, let me try something real quick. Just widen the screen. There we go. All right, cool. And so now we're going to do the same thing, but let's label these points. So let's say 1, 2, 3, 4, 5, 6. Let's do 1, 2, 3, 4, 5, 6. -1, -2, -3. And let's do the negative side over here. Got to take my time with this. All right, so now same thing, we're going to graph. I'm going to do these ones in a different color. -1/2 x minus 1. The y-intercept is -1. And then the slope is -1/2. So we're going to go down 1 to the right 2. Down 1 to the right 2. Down 1 to the right 2. We go in the opposite direction, up 1 and to the left 2. All right, this is a method that I use for graphing when lines are in slope-intercept form, and I've been using it for years and years and years. That's not the only way to do it, but I try to keep it simple. And a lot of times when you find out how to do a certain type of concept in math, you'll find a method that works for you and you'll keep it that way. So for the second equation, y equals 1/4 x minus 4, y-intercept of -4. And then the slope is 1/4, 1/4. So we're going to go up 1 over 1, 2, 3, 4. So that's the point of intersection right there. Up 1 over 1, 2, 3, 4. So we're out of bounds over there. Let's go down 1 and to the left, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And we can connect these. And this one you can see your point of intersection much simpler because we have an actual coordinate plane on here. So my point of intersection is this point right here. So your solution is, that's the ordered pair 4, -3. All right. So same thing applies if we substitute x and y into each of these equations, you should calculate out and get the same value on both sides. All right. So we're just finding what is that point of intersection. And even when we do the other methods, the elimination method and substitution method, really we end up searching for an ordered pair. Typically, depending on if you're having to do it by hand or not, for some people, if you understand graphing, then the graphing method would be the simplest way. Let's do one more example. Let's clear this up. And I didn't mean to do that. Well, I guess I can. Let's do 1, 2. Label these. Oh, that 4 is not looking good. Negatives down here, -1, -2. -3. All right, so we have the system y equals -2x plus 2, and then we have y equals -2x minus 2. Now, notice these both have something in common. Let's see how it looks, right? So the first one, -2x plus 2, so we have a y-intercept of 2 and a slope of -2, so -2 over 1. So down 2 over 1, down 2 over 1, down 2. Same thing. My phone is sliding. Go on the other direction, up 2 over 1, up 2 over 1, up 2 over 1. All right, and then we can connect those. And then we'll do the same thing. So this one, y-intercept of -2, still a slope of -2. So down 2 over 1, down 2 over 1, down 2 over 1, up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. When we connect these, we will notice that these lines are parallel. Now, some of you may have noticed from the beginning when you saw the equations, hey, they have the same slope. And you may remember that parallel lines have the same slope, right? So if they're parallel lines, they'll never touch. They're always the same distance apart from each other, or equidistant is the mathematical term for that. So you, when these lines never touch, if there's no point of intersection, then we have no solution, because the objective is to figure out where they intersect, and they will never intersect because they are parallel lines. So with that being said, that's the whole solution for that one. Few things to keep in mind if you are confused about how to use the substitution method and the elimination method, then by all means, go to the YouTube channel. I'll create a playlist with all 3 of these videos in there and look at those. But thank you so much for requesting these. Please do me a favor, like, share, subscribe. My whole goal is really to get these math lessons out to kids all over the world, just to make this mathematics stuff simpler. If you have a special request of a topic that you'd like me to do a video on, then by all means, send me an email, send me a DM if you're on IG. You can even put it in the comments if you want. I'll be honest with you, if that's not my lane, because I like to teach math that I overstand, not just understand. But if that's not my lane, I'll tell you, hey, look, I won't do that topic. But it's a lot of content out here still with the stuff that I do, several different levels, elementary, middle, high school, college level. But definitely send me a message if you'd like me to do a video for you. Remember, my name is Harris, Mr. Harris, Uncle Fuzzy, as my nephews call me, but Dana Harris, Young Gurus Math Tutoring, and I got the solution to your math problems. Deuces.